we're going to look at the proper ways to create a fragment, as well as looking at some basic communication channels to give information to a fragment and why those mechanisms exist. So we're going to start by looking at best practices for fragment instantiation, and then we'll talk about the most basic type of fragment communication, which is host to fragment. Now, a quick refresher about fragments. We always want to keep in mind what a fragment is. It's essentially a modular portion of an activity that we can use essentially in a composing fashion to create the functionality of an activity. Generally, when we create fragments, we want to limit the dependency with the outside world. We want to make sure that fragments know as little as is necessary about what exists outside of the fragment, and that will increase its modularity and its reusability. Despite all of this, however, it will of course become necessary for there to be some form of communication, both coming into the fragment as well as leaving it. So we are going to need to figure out ways to facilitate communication from the host to the fragment, from the fragment to the host, and indirectly from one fragment contained in a host to some other fragment or fragments simultaneously present in that host. So we're going to start by looking at ways that we can communicate from a host, in this case our activity, to a fragment. Now, this is the most straightforward mechanism for communication because this can essentially be done by just creating a set of public functions in your fragment definition. And then once the object or once the instance of your fragment is created, we just invoke those functions directly as we would call them from any other object in a program. So this essentially is no different. The activity just sees the fragment as it sees any other object, and you can just call functions to either mutate the fragment state or call accessors to get information about the fragment. So let's start by refactoring a program that we worked on last time. So we had created a simple image swapper. It was a program that had a fragment that was able to display one of a collection of images, and then we built in interactions so that clicking on the image contained in the fragment would have the image swapped to another random image. So here we added two instances of our image fragment via code. The image fragment had a set of images via their resource IDs. And then in our onCreate view, we would return the inflated layout, which is a layout that contains an image view. And we can see that here. So a relatively simple layout. And when we inflated the layout, we identified the image view in that layout, attached an onClick listener, and then performed that random switch whenever the item, the image view, was clicked. So that's the basic functionality. What we're going to do now is add some new functionality that is going to force us to sort of refactor our code. What I'd like to do here is on my main activity, I'm going to add a button. So as it stands, this is a little too big, so I'm going to need some space. So let me find, for the image view, I would like to find the layout constraint, the height value for my image view was 0.5. I'm going to set it to 0.45, 45%. I am going to then, for my second fragment container view. I'm going to just give myself some space. I'm going to add a button here. And the job of this button is going to be to change the image in my being displayed in my fragment. And in fact, it'll be to change the image displayed in both fragments. So we're just going to have this button sitting in between both fragment container views. And this will just be change image. So this will be my change button. And the goal is simple. The button will be here. And whenever I click the button, I would like the image to be updated. So instead of having to click the images directly, I want to be able to click this button to get the random image displayed. So that's my goal. In order to do that, I'm going to need to refactor my fragment. As it stands, the only method that allows the image swap to occur is clicking on the image itself, because the swap function is inside the onClick listener. So I'm going to refactor my code to allow for the changing of the image by calling a separate function. So I'll just create a function called change image. Helps to spell it properly. And its only job will be to essentially change the image in the image view to one of the values stored here. So doing that is going to take some refactoring. First, I had made this, I declared this image's value local to the onCreateView function. So that's not going to work anymore, because I'm going to need to access this property, or I'm going to make it a property. I'm going to need to access this array from my other function, so it cannot be declared locally. So if we just do this one at a time, as soon as I identify a problem, I'll fix it. So this is going to be a property. Well, I may need to make it a late init var. It will be an array. Type int. And then it can be initialized there. So now it's at least accessible outside. And then lastly, what I'll do is also make this image view accessible from my change image function. So I'm going to declare an image view. And then I will set that image view to be the image view I identify here. Now that I've identified it, I can, at this point, still apply an onClick listener. But this time, the onClick listener is just going to call change image. It is not itself going to change the image. And then in change image, I can now access the image view, and I can set its image resource to be images random. So that's the refactoring. Functionally, it looks the same externally, except now I'll be able to call change image both internally, but also externally, because it's a public function. So it means in my activity, I'll have the ability to invoke the change image function when my button is clicked. So I'm going to find my button, give it an onClick listener, and then the goal of the onClick listener will be to invoke the change image on both of these fragments. Right now, I do not have a direct reference to these fragments because I simply instantiated them and passed them directly to the transaction, which attached them, but I don't have a reference directly in my activity. Now, I can get the references from my fragment manager, but let's just keep it simple. And instead of doing that, I'll just create my fragment variables. Pass those fragments in. And now I have a reference to the two fragments that were passed into the transaction, and I can therefore access their change image function. And that's it. I'm able to have information pass from the activity, in this case when I click the button, to the fragment by simply invoking the change image function. And I could just as easily have passed data in by simply defining an argument for the change image function and passing that information in. So running this updated application, not only can I change the images by clicking on the image itself, but I can also simply hit change image and I get them changing at the same time. And of course, the original functionality is still maintained. Okay. Now, there are a few shortcomings, a few problems with the way that we've designed our applications so far. The first one I'd like to show you is something that could happen if I wanted to have, let's say, a default image, or at least an initial image, be displayed when my application first starts. So you'll notice when the application runs, it starts with two empty image views. Clicking change image will give me two images. But what if I wanted my application to start with displaying two images? Then it might seem like one way I could do this is simply in my onCreate, I could call fragment1 change image and fragment2 change image. This would then invoke the change image function on both fragments when my activity starts. And you'll notice I'm executing these calls to change image after we execute or we commit the transaction to attach the fragments to the activity. So let's see what happens when we run our application. Well, whatever that was, it was bad. Let's do it one more time. All right, now we're seeing error messages. So let's examine that error message and see exactly what's going wrong. So under run, I'll just as easily have gone under my logcat, but I'm seeing a stack trace. And whenever we see a stack trace, we always want to look for two things. We want to look for the message provided by the exception. Hopefully it will be clear enough for us. And then we want to find which lines of code threw the exception or caused the exception to be thrown. And you're looking for your code, not necessarily framework code. So here I see that it was image fragment line 44, which was itself invoked by main activity line 27. So we could examine those two lines to see exactly what it is. So this is 27. I'm calling change image. And then in the fragment class, it's line 44, set image resource. Okay, so this is crashing. And what is the message? The message is uninitialized property access exception. Late init property image view has not been initialized. So what's happening here? Essentially, when you create and subsequently execute a fragment transaction, the operations specified in that transaction are executed asynchronously. Essentially, there's a bit of concurrency happening here. The transaction operations are, in effect, pushed to the background, and we, in our code, have no real guarantees about when those operations are going to be performed. In the meantime, our main thread continues to execute the rest of our statements, even though the transaction isn't yet complete. This can cause issues if our main thread thereafter attempts to access elements from the fragment, especially UI elements. So in our code, we create two fragment instances and we attach them using a fragment transaction. And subsequently, within our activity, we try to call change image on those fragments. But if we take a look at our image fragment class, we can see that we have our image view and our images property for that matter declared as late init, which means that they'll be given values or they will be initialized later on. And sure enough, those values are initialized in our onCreateView function. onCreateView, however, is a callback function in the fragment's lifecycle. And because we have no control over the execution of the lifecycle, because again, that add operation is being executed in the background, when the fragment goes on to call change image, it turns out image view has not yet been initialized, and neither would images. So we would essentially attempt to access a property that does not yet have an object. So it's similar to a null pointer exception, except it happens to be an exception relating to accessing an uninitialized property, because we said that this was a late init, but it's the same idea. So it turns out that whenever you want to set up the fragment state at the time it's created, it is not sufficient to simply invoke setter functions on that fragment, because you might be attempting to set something up before the fragment is ready. Instead, you have to write your code in such a way that the fragment sets itself up when it's ready, instead of having the function be invoked externally. So for a fragment, there are a few ways that you can do that, but one of the most straightforward ways is to use another callback function called onViewCreated. onViewCreated is a callback function that gets invoked after the layout has been inflated, returned, and the fragment is attached. So when onViewCreated is invoked, you know that the view for the fragment is ready. The layout for the fragment is inflated and all the items are in fact initialized or not null. So our image view is going to have a value at this point. So what we could do then is, instead of having the activity call change image to have the fragment display a startup item, we will have the fragment do that on its own with a call internally to change image. Now, whenever we run our application, each fragment at the time it's attached and it's ready to go will show a default image, and that will be every time. So that's one of the things that you need to be mindful of when you're designing fragments. How do I give it information so that it knows what it should do at the time it is created and at the time it's attached? But this is a part of a larger problem. If we take a look at my fragment, you'll notice something. Right now, it's displaying images of desserts. And those images are hard-coded into my fragment implementation. I literally have all the images spelled out inside the fragment itself. So if you think about this, you might start to see how this can be a problem. One of the goals of fragments is reusability. But the way I've used my fragment here, it reduces its reusability to a great extent. Within my application, for example, this fragment can only display images of these desserts. It can't really do anything else. What if I wanted to display images of something else, like my favorite desserts? So in addition to having a set of images for cakes, I also have images for, sandy areas. So how could I have my application display images of desserts in some cases and images of deserts in other cases? Well, one way is to potentially add a collection of desert images alongside my collection of dessert images, and then tell the fragment which one it should use at a given time. But you start to see that that's not a real solution. Because what happens if I have a third set of images or a fourth? What happens if the images are coming from a different source, such as downloaded from the internet or from a set of files? Basically, what I would like to do is have a fragment design that does not know the source of the information that it's going to operate on. Rather, I would like to have that information provided to the fragment at the time it's created. So what we would like to do is provision the data that the fragment can use when it is created. This will ensure that our fragment is not tightly coupled to any specific data source, and its usefulness is improved because I can now use that very same fragment whenever I want to display a random image from any collection. Now, we could create a fragment and then simply pass in an array. But if we do that using normal setter functions, then we run into the same problem we had before of early access. How do I know that the fragment is able to accept the images? It may not be ready to. So I may run into issues if I take that approach. Now, thankfully, Android provides a feature, a mechanism, if you will, to provision fragments with information at startup by using the arguments property. So the arguments property is literally just that. It's a property in a fragment that can hold information, and it is absolutely the preferred way, the recommended way to do this, unlike what others might be tempted to do. For example, in almost any other case where we want to provide information to an object at startup, we would simply give that object or give that class definition a constructor and have that constructor accept the data that we want. But with fragments, that actually won't work. And the reason it won't work is a little complex, but essentially it has to do with the fact that Android can, in a manner similar to the way it can kill and restart activities, Android can kill and recreate instances of your fragments. And if we went around giving constructors to our fragments, Android would not know which constructor to use when it wants to recreate an instance of your fragment. So it would not be able to, for example, provide the data when it recreates your fragment. It may not be able to provide the data that it had initially. So we do not use constructors when we want to give information to a fragment. Instead, we use arguments. So here's what that looks like. So the first thing I'm going to do is I'm going to get rid of this collection. I'm not going to delete it since I have to retype it, but I'm going to move it into my activity just for a moment, with the understanding that this could be any collection from any source. It just so happens that these are, in fact, my resources. So these will be my dessert images. And now what I would like is another collection that we will call dessert images. I hope this is not as confusing for you as it is for me. And then, much like above, we will type out each of these values such that we have a full collection of images. Then lather, rinse, repeat. And there we have all of our desert images. So I have these two collections, and what I need to do now is refactor my fragment class in such a way that it does not use images defined internally, but rather uses a set of images that are provided at the time the fragment is created. So here's how this is going to work. The first thing we're going to do is revisit an old friend. We're going to override our fragments onCreate function. So this is a function that we've seen before because this exists in our activities. And it is, in effect, the first function that gets invoked in our lifecycle. Now, there are others that, another function that gets invoked in a fragment called unattached, but we'll ignore that for now. But onCreate is invoked prior to onCreate view. The idea is that onCreate is a function that gets invoked, and upon its invocation, you should use it to set up the state of your fragment. Whenever you hear the word state, you can just think of properties. We're talking about the information, the data that is being stored. So for us, the data that my fragment cares about is this collection of images. So the goal of onCreate is to set up the state of the images property, or initialize images with an array. So here's how we're going to do this. Inside every fragment is a property called arguments. That arguments property is of type bundle. Now, a bundle is essentially just a name value collection where you provide a name or a key, and there is some value associated with that. Now, the arguments property can be null, so we can just use Kotlin notation to execute certain things if it's not null. And in this case, what we're going to do is for every image fragment, we are going to expect the presence of an int array. So the type that our fragment is going to operate on is going to be an int array. Now, what I have above in my actual class definition is an array of type int. So for simplicity, I'll just modify this. So I'll just say, well, now we're going to operate on int arrays because that's what the bundle type supports. So at this point, I'm now being asked to provide the key for the int array. Essentially, it's going to look inside of the bundle for an int array of a given key. So I'm going to need a key. So let's define a key. I could use a constant value. It really doesn't matter, but let's just call that image array key is whatever we would like it to be. So image array key. Now, when Kotlin attempts to fetch an int array with this key, it may actually not find it. So the return type for this function is a nullable int array. So what I would like to say is if you find it, then execute this scope function and initialize images with the int array that you found. So this will only execute if the item is there. So this is a very safe call. If you don't want to use the various Kotlin notation and the syntactic sugar, then you can just do a series of if then else statements. But this is essentially ensures that I only assign the int array if I find it. Otherwise, I may choose to initialize images with something else, with some default. But I'm going to write my application in such a way that we're always expecting this int array to be provided. So this is how my images will be set up. Now that it's initialized, everything else can function the way it should. So as long as you provide the int array and you provide it via the arguments function. So for the rest of our application to work then, my activity needs to provide these values, which right now are just arrays. So I'm going to change this. So instead of it being an array of, it will be an int array of, in keeping with the new design of our fragment. So again, I have that shortcut function, that convenience function that can just give me an int array from a collection. So I've defined these. Now what I need to do is for these two fragments, I need to give them the information. They need to give them these values. So what I'm going to do is, having defined them for fragment 1, I can assign the arguments by placing these items inside a bundle. So I'm going to create a bundle. And inside that bundle, I'm going to put an int array. The key will be the same constant value I defined here, which was image array key. And of course, the int array will be my desert images. Now that I have that bundle, I will set fragment 1's argument property to be the bundle. So this is how the fragment is initialized. It's given this bundle for its arguments. And I'm doing this, I have to do this before I attempt to attach it via the fragment transaction. So I've set up fragment 1. I can now do the same thing with fragment 2. It will just be bundle. And then fragment 2 dot arguments is equal to bundle2. And that's it. If I now run my application, I'll see that my now decoupled fragment can display different images depending on the collection that I provide. So I can get my favorite desserts and my favorite deserts being displayed. And now it's very generic. So now my image fragment can be used in different places. Now, this is the proper way to design a fragment so far. But you might notice a problem here, and that is we've got quite a bit of boilerplate code here. A lot of this stuff is kind of repeating itself. And as a result, you might immediately start to think, well, is there a more straightforward way of doing this? Can we combine all of this repeat code into something? And the answer is, of course, yes, right? This type of repetition is begging to be placed in its own function. So I can sort of address this repetitiveness by just creating a function. So the question becomes, well, where do I put that function? So, okay, I could put that function in this activity, and I think that would be a very good start, because at the very least, it would mean that I wouldn't need to have this repeated in this activity. It would just be in one single function that I could create here. So I could create a function that either accepts all the values that need to be placed in the fragment and then create a fragment, place the values there, and then return it so that we can use the fragment in the rest of our code. Or I could provision the fragment with the data and then simply place it inside of it by having this boilerplate code written just once. And I think any of those solutions would be fine for what we've identified as a potential approach. However, what we're going to quickly realize is, yeah, that works for this application and it works for this activity. But what if another activity in my application also wants to use that fragment? Am I going to then repeat the code? All right, then maybe I put the code in a helper a helper class that sort of provide utility functions. Again, I might say, well, that's good. But what if I want to use this fragment in another project? So now I need to move the class to another project. I would also need to use or to move this utility or this helper class along with my fragment. So essentially these two classes would now be very coupled because they'd have to move together because they would almost need each other. So none of these are ideal. Rather, what we would like to do is to use what's called a factory method, or since this is Kotlin, perhaps a factory function. But we essentially would like to create a function that is able to do all of the boilerplate code for us, which is already something we've talked about and we've decided that's probably the best approach. But in order to figure out what's the best place for this function, we should ask ourselves, what artifact, and an artifact in this case is anything, right? And anything can be referred to as an artifact. So when I ask the question, what artifact will always be present whenever I have an image fragment in a project? Well, the only answer to that is the image fragment. The image fragment class is the one thing that will always be present whenever I have the image fragment class, right? That's a very tautological statement, but it's also a very true statement. As such, if I want this factory method to be available to me wherever the image fragment class is, then the best place for that factory method is the image fragment class itself. So essentially what we're going to do is provision our image fragment class with a function that allows us to always have a properly created image fragment instance. You can create as overloaded versions of a factory method to ensure that you can create different types of instances of your object if needed. But oftentimes a factory method will just be a single function that it takes all the information that is needed and returns a useful or a properly instantiated instance of the object, in this case, our fragment. So let's essentially take this code and place it inside of a function in our image fragment class that we can then use to create instances of an image fragment. So to do that, I'm going to create, first thing I'm going to do is create something called a companion object. In Kotlin, a companion object is literally just an object that is associated with or is a companion of your class. Whenever your class is accessible, that companion object is instantiated and you can essentially access properties or functions defined inside of this object. This is very similar to the way that we can create static properties and static methods in a Java program. In fact, when you specify a companion object and you provide properties or functions at the bytecode level, a companion object and all of its members are actually converted to static references in Java or at the bytecode level. So it's a similar concept, and it will allow us to basically call a function on the image fragment class in the same way we could call a static function on an image fragment class in Java. So inside of this object, I'm going to define a function, and I'm going to give that function the name new instance. This is a very common pattern to use when creating factory methods. The name sort of tells you what's happening. When you call new instance, you're basically saying, give me a new instance of this particular class type. You may also see functions with the name get instance. Usually if you see get instance, it's probably some sort of singleton pattern, meaning there's only one version of the object, and every time you call get instance, you're getting the same version. You're getting a reference to the same object. New instance tells us every time I call it, I'm getting a new object. So when you're calling, or you're defining rather, a factory function or a factory method, the arguments here are the things that are supposed to be placed inside the fragment. So for us, the thing that we want is the images, which will be of type int array. And this function is going to return an object of type image fragment. It does not like that I'm using val. It's fine. So we're going to get the int array argument passed into our call to new instance. And then new instance just needs to do a few things. First, it needs to create an instance of the image fragment. So yes, our function defined inside of the image fragment class can create an instance of image fragment. That is perfectly allowed. From here, we need to then create a bundle. Now, it turns out I already have that code, so I don't need to write it again. I'm just going to take pretty much all of this and then modify it inside. So I have a bundle. Inside of that bundle, I will place, using the image array key, which we defined here, I'm going to have images. And then my fragment will have the arguments be initialized with the bundle, which we're currently calling bundle2. And then once I have that, I'll return fragment. So this is what the function is doing. It is taking in an int array called images, It creates an instance of the fragment, creates a bundle, places the images inside the bundle, initializes the arguments property of the fragment using the bundle, and then it returns the fragment. All right. So all of this could be simplified, if you will, if you would like to see the Kotlinized version of this. Essentially, we could simply do an image fragment. But on this image fragment, we're going to apply arguments. And that is going to be equal to a bundle. On that bundle, we're going to apply put int array images array key images. So that's the same thing, functionally the same thing. We're just using scope functions to make our code a little more succinct, but it's essentially the same thing. Creating a fragment, setting that fragment's arguments property to be this bundle, and inside of that bundle, I've put an int array with the key image array key and the value images, which is the argument that was passed in. So now that I have this this factory method, now whenever I want to get an instance of image fragment in my code, instead of doing all of this, well, now it matters where I define this. So instead of doing all of this, I'll now just say val fragment1 is equal to image fragment dot new instance desert images. And then similarly, val fragment2 is equal to image fragment dot new instance desert images. All of that boilerplate code now resides here. So now to create a proper instance of image fragment, I just need to call this function. I run my code and it works exactly the same as it did before, but now my code is so much cleaner. So those are the mechanisms we have for providing information to a fragment, whether through a function call invoked externally from the host, or providing information to our fragment that it can use to set itself up. And we see here that we can have the same fragment type displaying different sets of images simply by making sure that the fragment is not coupled to the data source, but rather the information is provided to the fragment at the time it's created.